Hello and welcome to the BMC Learning Series. Today we'll be covering MainView SRM Allocation Part 2. In this second of a three-part series, we will continue our look at specific SRM allocation functions. If you have not taken the Part 1 session, please do that first. The SPACPRIM function will decrease the primary space request by a defined percentage if the original request cannot be satisfied in the first 5 extents. The function incrementally reduces the primary space request using a defined percentage value. In addition, a low-level value limits how far to reduce the primary request. As with all allocation rules, the values can be selectively applied to just about any resource associated to a dataset. SPACPRIM works for all dataset types to prevent space not available JCL errors at allocation time. It is recommended not to use a low decrement value, such as 1%. The RList set statement for SPACPRIM contains just two, SPACPRIM equals and event ID equals. For the functions that start with SPAC, the RList set statement will always be the function name, along with the type of action to take. For SPACPRIM, the actions are to decrease the requested primary space by a percentage. This is the second value and the decrement value. The second value is the floor limit, or the lowest allowed value of space before failing the allocation. If only the floor limit is specified, the decrement value will be 10%. This is true of SPACSECR and SPACSWIR, which we will discuss later. The global sysparm value of US non-BFIT specifies whether MainView SRM should bypass the DF-SMS non-BestFit volume selection process when the IBM IDCAMS utility is used to define an SMS-managed dataset. When the value is set to no, it only works if SPACPRIM is active. The global keyword of SPACPRIMX will ignore the reduction percentage in the SPACPRIM rule for the SMS managed datasets and adjust the primary to fit on the available space in the DF-SMS storage pools. The default value is yes. The messages that are produced from SPACPRIM recovery actions identify the type of action or inaction that occurred. For a successful reduction of the primary request, message SVM4771I is issued, informing the end user of the reduction amount. Other messages will inform the end user if the floor limit was reached and therefore the allocation was unsuccessful, or that the reduction request could not execute. Here are some examples of coding the SPACPRIM function. Our smfuncNN member will display all messages to the console, yet will not write information messages to the SMF record because we have SMF equals E coded. For the resources considered, we are going to exclude all datasets that have less than 50 kilobytes requested for the primary request. We have several rules in our RList. The first set statement is to allow a reduction of only 10% of the primary request for datasets with no secondary space coded. The second set statement will not reduce the primary more than 60% of the requested amount for any physical sequential dataset whose size is greater than 100 megabytes. The third set statement will not reduce the primary more than 80% of the requested amount for any datasets between the size of 100 megabytes and 300 megabytes. And the final set statement reduces all remaining datasets to a reduction of 40% of the requested amount in increments of 20% of the requested amount. The SPACRLSE function will release unused space for physical sequential datasets if the release keyword is not coded in the JCL. There are other methods, all of which are either manual, time-consuming, or require additional CPU during space management cycles and are not as flexible. Excellent storage management practices will include the releasing of unused allocated space as it saves on the cost of DASD. The function does not actually release. It invokes the release parameter. For datasets allocated using the ISPF 3.2 services, the function is not invoked. The RSLT set statement parm is the release with one of three options. All releases space for all eligible datasets. Sec reduces space for datasets with a secondary quantity. No turns off the release flag. There are no global sysparms that affect the function. The informational message that is displayed validates that the release parameter was assigned to the dataset displayed in the message. An example of the SPACRLSE function. Again, all messages are displayed and non-informational messages are cut in the SMF record. We define some variables to be used in the R list. A variable of DLY work is defined using values for transitory work files that should not have space released. This variable is a useful variable as it can be used in other functions as well. The F list excludes the variables we have defined and includes other datasets for consideration for space release. There are two R list set statements. The first rule releases space only for jobs with the secondary space coded and execute with a job class PFP. The second rule releases space for the remaining datasets. The SPACSECA function adds a secondary allocation to datasets if none was specified. The function is invoked before allocation. Since datasets that do not have secondary space cannot extend, any jobs loading data will abend when the primary space is exceeded. The value of the secondary space is a percentage of the primary and provided by the user in the SPACSECA R-list rules. Excluding DB2, IMS, or KICS datasets and other system-related datasets is suggested. The R-list set statement for SPACSECA sets the percentage amount of the primary that will be used to allocate a secondary space value. The percentage can be larger than 100, making it possible to allocate a secondary space value much larger than the primary. As with SPACVOLA function in allocation, SPACSECA has a no-check parm to bypass certain processing. Contig is the only valid option for SPACSECA. There's a global sysparm, vsam-zsec, which is used to determine if SPACSECA or SPACVOLA will control the recovery. If the keyword is set to yes, then SPACSECA will provide the action to add secondary space. If the value is no, then SPACVOLA, that's volume add function, will control the recovery. We will discuss SPACVOLA later in the session. The message is only if the secondary is added, stating the percentage of the primary space value. If the dataset is vsam, then additional information about the data or index component will be displayed. The example for SPACSECA is to display all messages and only cut error messages to SMF. All datasets are available for consideration based on the include statement in the F list. The first set statement in the R list will add a secondary allocation of 30% of the primary to vsam datasets that are larger than 50 meg. The second set statement adds a secondary of 100% of the primary to all physical sequential datasets that have a low-level qualifier that begins with tran. And the last set statement adds a secondary allocation of 10% of the primary for all other datasets. The SPACSECI function increases or decreases the secondary space quantity. This function is not a recovery function. The actions taken are not a result of an out-of-space condition. SPACSECI can be used to prevent out-of-space conditions or even prevent other allocation functions from being called because of an out-of-space condition. The function will apply the RLSE process at dataset close. The SPACSECI function applies to physical, sequential, and partitioned datasets. The params in the SPACSECI set statement determine the percentage increase, at what extent, or even the set secondary quantity of space during the extent processing. The SPACSECI keyword must be specified. The parameter determines the extent number at which the percentage is increased or decreased, or the secondary space is changed to a set quantity in cylinders. PCTI is a percentage increase or decrease. If the value specified is less than 100, then the function decreases the secondary extent by that percentage of the original secondary request. There is no change if the value is 100. If a volume is added during extent processing using SPACSECI, then the first extent on the added volume will be the original space request value from the JCL. PCTI is not invoked on the first extent of a volume add. SQTY will add a set value of space in cylinders. When SQTY is used, every added extent will be given quantity of space, even if the first extent on a volume add. There are no global sysparms for the SPACSECI function. The displayed message issued by SPACSECI informs the user of the increased values of space on each extent. The SPACSECI example at the SM-Func member is similar to the other definitions. All messages are displayed and only error messages are cut in the SMF record. The F-list is active and all datasets are considered for the action. The first set statement in the R-list will increase the secondary allocation after the 8th extent for any datasets starting with MSTR. The second set statement will set the secondary space quantity to 25 cylinders after the 5th extent for all datasets with the 4th node starting with TRAN. The third set statement will increase the secondary by 200% of the original secondary request on all datasets after the volume add. And the last set statement increases all remaining datasets after the 10th extent. The SPACSECR function reduces the size of the secondary extent if that space cannot be found. The SPACSECR and the SPACVOLA functions are driven during end-of-volume processing. The intent of this function is to attempt to keep the dataset on one volume. Both SPACSECR and SPACSECB reduce secondary allocation. However, SPACSECB gets control before allocation, not after. Therefore, SPACSECB can be used to best fit allocations in tight pools. SPACSECR will reduce the secondary amount of the single largest extent, which is normally allocated in up to 5 extents. There are limitations to SPACSECR as it does not process DB2, KSDS indexes, or KSDS with key ranges, mostly because of the way those data type sets work in the access methods. The SPACSECR R-list set statements work in similar fashion to the SPACPRIM set statements. There's a decrement value and a floor limit value. The first value is the floor limit, while the second is the decrement value. Again, as in SPACPRIM, the only no-check value that is valid is contig. As mentioned before, you can create events to be sent to the console. The SPACSECR function does have 2 global sysparms. mReduce, which allows secondary space reduction, can occur on multi-volume datasets allocated by JCL. The VSAM lim warn is used by several functions which warns users when a non-extended format of VSAM dataset is approaching the defined threshold percentage. This is only one message produced for a successful reduction, which states the original amount and the new amount. The SM-Func set statement for SPACSECR is the same as our other examples. Only error messages to SMF and other messages are displayed. Our F-list member suffix is 00, the R-list member suffix 29. For our F-list definitions of resources to consider, we will only do jobs with Job Act 2 values that start with prod. Our R-list member has 3 set statements. The first sets a floor limit of 60% of the requested amount for jobs in classes A, F, and S. The second set statement sets a floor limit of 30% of the requested space using a decrement value of 20% for jobs running in classes K and U. The last set statement sets no floor limit for all jobs in class C. The SPACSWIR function works similar to SPACSECR in reducing the size of extents, with the exception that SPACSWIR works on the first extent of a volume switch. SPACSWIR works with the SMF managed datasets and data class volume counts, SPACVOLA add volumes, and JCL defined candidate volumes. When candidate volumes are involved, SPACSWIR will get called before SPACSECR and SPACVOLA. When setting up the F-list for resources, SPACSWIR and SPACVOLA should look the same. The SPACSWIR R-list set statements are similar to SPACPRIM and SPACSECR. There's a lower floor limit and the decrement value. The no-check values are for EXCP, note, point, and contig. There are sysparms for SPACSWIR. VSAM prime is used to determine which VSAM allocation value to use on the volume switch. If no, then the secondary allocation amount will be used, and if yes, the primary amount will be used. VSAM prime does not apply to multi-stripe VSAM and IBM DB2 VSAM datasets. We've discussed VSAM limb-worn as a global. Skip is used to bypass the global level what no check provides in the R-list member. Skip would bypass contig, EXCP, note, and point logic during a volume switch. DC type is used to provide the same device characteristics for cached volumes during a volume switch. In today's technology, DC type is rarely used. The message that is displayed looks similar to SPACSECR message, the original space units and the new space units. Okay, here's an example of the SPACSWIR function. In the SM func member, we have changed our messages and SMF values to only display error messages, and they do not write anything to SMF. Our F-list contains an inact statement informing SRM not to consider these resources for VACSWIR. The resources not to consider are any datasets starting with test journal or prod.gl. The resources that are considered are test.anything datasets or prod.anything. The first R-list set statement will set a floor limit of 30% of the original request for the test datasets. The second set statement sets the floor limit of 50% of the request for all the prod datasets. The SPACVOLA function is the volume add function. Volumes are dynamically added when either the maximum number of extents is reached on a volume, or there is inadequate space for the extent to process on the current volume. The function applies to all physical, sequential, and VSAM datasets, both SMS and non-SMS. There are data types and certain access methods processing that SPACVOLA by default does not use. Uncatalogued datasets cannot have a volume added. Neither can VIO data. Data specified in JCL with a vol equals ref or concatenated cannot have a volume added. Data that is processed with a note, point, or EXCP by default cannot have a volume added. Yet there are global parameters that will bypass these checks and allow secondary volumes to be added. For non-SMS data, volumes are added based on the SM pool definitions. Parms on the SPACVOLA R-list. The set statement sets the maximum number of volumes to be added to any dataset. The other parms are optional and provide the ability to set a percentage increase, PCTI, extend to an alternate SRM defined pool, extend to different mounted device, do not check for certain access methods, set a secondary quantity of data, reorg multi-volume datasets later on, and use the current pool to search for volumes. Listed here are the messages displayed to inform the user if there's a failure or the reason for the failure. The successful message informs the user of the number of volumes that the dataset has extended onto and the number of extents involved in the previous volume. The global sysparms that work with SPACVOLA are many. MaxVol can set a global value for the maximum number of volumes an allocation can use. The RLEST SPACVOLA equals X can override this value. VSAM prime we've discussed already. VSAM ZSEC we have discussed with SPACSECA. A reminder is that this value determines which function controls recovery. The SMF ID parm is for all the allocation functions to identify the SMF ID to be cut for SRM activity. Examples of SPACVOLA function. Only error messages are displayed and nothing is written to SMF. The FList excludes all datasets that begin with test.journal and prod.gl. What is considered for SPACVOLA is the remaining datasets that start with test and prod. For the RList, the maximum number of volumes to add for test datasets is 3, and for prod, it's 6. MainView SRM allocation provides a series of batch jobs that can assist with new DF-SMS implementations, or to just validate the construct values that currently exist. Other batch jobs can synchronize the currently allocated datasets of the ACS routines. An example would be a management class has been removed from the constructs. The management class synchronization job will create alternate statements as control card input to change the currently used management class to the management class that should be assigned based on the current ACS assignment routines. There is a single sample batch job located in the BBSAMP library. In order to validate the actions that SRM allocation has taken, or event check for additional possible recovery actions, MainView SRM provides various methods for reporting or viewing these activities. As noted, the MSG parameter generates messages to the job log and the syslog. The SMF parameters will cut SMF records that can be used as input into various SRM batch jobs. In addition, the SMDiag member can be used for tracing purposes to debug or validate the rules within SRM. That concludes part 2 of this series. For more videos on MainView and other BMC solutions, please visit our BMC Mainframe YouTube channel at youtube.com/user/BMC Software Mainframe/featured. That's it for this session. Thank you and see you next time.